The cerebrospinal fluid flows through the brain at 0.3 millimeters per second, a rate precisely calibrated to wash away toxins. This steady stream is not just water, it carries the waste products of neural activity, including beta-amyloid proteins that can accumulate and disrupt function. The interstitial space, where this fluid moves, expands during sleep, ensuring the fluid can effectively reach and clear these toxic proteins. But the thresholds of flow rate and space expansion are not met. The brain's vital maintenance system falters. Sleep disruption can reduce this expansion, leading to a buildup of beta-amyloid. This buildup has been linked to cognitive decline and neurodegenerative diseases. The failure state is clear. Without the alignment of these coupled thresholds, neural health is compromised. The delicate balance between fluid flow and space expansion determines the fate of our neural well-being. In 2013, colleagues used two-photon microscopy to peer into the brain during sleep. They observed a significant increase in interstitial space volume, expanding by up to 60% to create wider channels for cerebrospinal fluid flow. This expansion sets the threshold for efficient fluid dynamics within the brain. Without this increased space, the flow of cerebrospinal fluid would be hindered, compromising waste removal. In 2015, Nedergaard and her team used in vivo imaging to observe cerebrospinal fluid flow in real time. They found a marked reduction in beta-amyloid clearance during wakefulness compared to sleep. This quantifiable difference highlights the brain's reliance on expanded interstitial space for efficient waste removal. Chronic disruption of this expansion can lead to higher levels of beta-amyloid, a neurotoxic protein. This increase sets a critical threshold for cognitive impairment. In 2019, Muzik and colleagues used advanced imaging techniques to study the effects of chronic sleep deprivation on the glymphatic system. After just 7 days, they observed a 25% reduction in glymphatic efficiency. This finding highlights a critical threshold. Sustained impairment of the glymphatic system can lead to neurodegenerative risk. This reduction in interstitial space impairs the brain's ability to clear toxins, leading to a cascade of neuroinflammatory responses. These inflammatory reactions exacerbate cognitive decline and increase the risk of neurodegenerative diseases. The glymphatic system operates within a narrow margin of tolerance. A 25% reduction in efficiency due to chronic sleep deprivation is not just a statistical blip. It's a critical point where the brain's ability to clear waste begins to fail. In 2021, Liu and colleagues used computational models to simulate the glymphatic system under various conditions. Their findings revealed that even a slight disruption in interstitial space expansion can lead to a significant decrease in waste clearance efficiency. The intricate balance of fluid dynamics within the brain is not just a matter of sleep quality, it's a survival mechanism. Chronic sleep deprivation disrupts this balance, leading to a systemic failure that can have profound consequences on neural health. The alignment of these thresholds, cerebrospinal fluid flow, interstitial space expansion, beta-amyloid accumulation, and the impact of sleep disruption and chronic deprivation, reveals the intricate balance required for the brain's self-cleaning mechanism to function optimally. Each threshold must be met with precision. Any deviation can exponentially increase the risk of neurodegenerative diseases like Alzheimer's. Consider the cerebrospinal fluid flow as a river. Its current regulated by the expansion and contraction of interstitial space. This dynamic dance ensures that toxic proteins are flushed out efficiently during sleep. When this rhythm is disrupted, even slightly, the accumulation of beta-amyloid can begin to form plaques, leading to cognitive decline. The interplay between these thresholds creates a complex system that is both robust and fragile. The cerebrospinal fluid must flow smoothly, the interstitial space must expand adequately, and toxic proteins must be cleared efficiently. This balance is essential for preventing the accumulation of harmful substances that can lead to neurodegenerative diseases. Understanding this mechanism provides a deeper appreciation for the brain's self-cleaning process. It is not just about sleep. It is about the intricate dance of physiological processes that must align perfectly for optimal function. The joint improbability of meeting all these thresholds highlights the precision required for the glymphatic system to function effectively. Any deviation from this delicate balance can have profound consequences. How does the alignment of these thresholds impact other neurological processes? Join us next as we explore the role of inflammation in brain function.